Hello everyone, and welcome back to another episode of Base Physics. In today's episode, we are going to talk about Newton's laws, which basically is what you go over probably in the first week of any physics class you have. We're going to just go right into it. Newton's first law. Newton's first law states that an object in motion stays in motion, while an object at rest stays at rest. So you've probably heard this before in cliches, like probably in like a medicine ad or something like that. But it is true. It's essentially saying that if something has no other forces on it, nothing will change. And that makes a lot of sense. So some examples of this are Usain Bolt literally never stops running. That's a fact. Um, and then this guy right here is always laying on the couch. He doesn't do anything until his mom yells at him to take out the trash. So until somebody or something exerts a force on someone, um, they stay in their same, they stay just doing what they're doing. You might think, how come if I roll a ball or something like that, why doesn't it just keep going forever? And the reason for that is that it's because there are other forces acting on it, like maybe gravity keeps it from rolling up the hill, or usually it's going to be the frictional forces. Like anything has some friction, so you roll a ball on the ground and the friction is what's going to stop it from rolling. Okay, here goes Newton's second law. What this means is it's just an equation. Force equals mass times acceleration. So a good application of this equation is saying something like, if you know two of these things, like if you know force and you know mass, you can always figure out what the acceleration is. And that's a pretty interesting thing. So if you essentially what you can take out of this equation is the bigger and more massive that something is, the more force you have to exert to get it to speed up. And I feel like this makes a lot of sense, right? Because if you think about it, you can just think about this in your life. Like, good luck pushing this massive boulder. I mean, basically only the Hulk's gonna be able to push that. And this pebble, right? You can easily push that. Although you can exert a lot more force than an ant, right? So for an ant, it's going to be much harder to push a pebble than for you because you can exert more force and therefore you can put more acceleration onto an object. Newton's third law is something that is something you don't really think about but is very true in life. And essentially what it states is that every action has an equal and opposite reaction. So every force has an equal and opposite force pushing back on it. So it was originally said by this man around 500 BCE. And you can see this again in real life. Like, for example, if you steal someone's chicken nuggets, expect your house to get blown up because that's an equal and opposite reaction to what's going to happen. This is pretty applicable in life. Um, and if it wasn't true, then we'd have a lot of problems because when you step on the floor, you press down on the floor, right? But if there was no opposite reaction pushing you back up, you would just sink into the floor. I know that would just create a bottomless pit, and that might sound cool for maybe 5 seconds, but you do not want to be in a bottomless pit for the rest of your life. That would suck. Okay, so thank you guys for watching. This has been Based Physics Explains Newton's laws of motion. I'm trying to explain physics concepts in a good way while also adding a little bit of humor. So let me know if my jokes were funny or not. I'm not a stand-up comedian. And other than that, I'll see you guys in the next video. Comment what you want to see down below.